Okay, moving on to task 4 of assignment 1. In the comments it says plot the trajectory, it's just one trajectory, isn't it, from task 2 and 3. Let's move up to the instructions just to confirm. Use the plot function to generate a figure showing the first trajectory. Use MATLAB commands, and here's a link that you can click that will take you to something useful, to add an appropriate title, axis, grid, and legend. So plotting is so useful. It checks if you've got the right answer. You should use it every assignment and in the coursework to make sure you've got the right answer when you don't have a pretest. Okay, let's do that. So you could go to MATLAB help, write plot, and what you'll learn is the following, okay? So you can plot the values of a vector, of one vector, against another. So you want lots of different x, y positions, each dots with each of a different value of x and y, x and y, x and y to appear on a graph. What you can do is you can pass a vector with the values of x first for the x-axis, and then a vector of the values of y for the y-axis. Let's just run that and see what happens. Okay, this data table is really annoying. Okay, we see something that looks like it could be a trajectory of a rock. Looks about right. So let's remove this printout of this data here, because this is a bit annoying. I'll make sure to have that ready before you doing this assignment. Okay, great. We've got an initial picture. So if we clicked on that link in the tasks, it would show us how to put a label on the figure. Excuse me. So we can put an X label by writing X label like this. We can put a Y label by writing Y label, and what goes in here is what's written on that label. So we can just test that out, and it will appear on the figure. We'll just automatically add these labels by writing that code. So now this data will no longer appear because we put a semicolon after it. Beautiful. X in meters, Y in meters, starts at about 3.5 something, 3.5 about, and then shoots up and lands. So it lands at Y0. Looks correct, right? So these are all confirmations that this looks right. Let's add some more details to the figure. We're told to add a title, so we can just do that by writing title, projectile trajectory for θ1 launch angle, whatever you want. You can also have a legend. Now I'm writing the legend part in LaTeX code. You do not need to worry about the details. It's just what's going to show that, specify exactly what is the line mean. And we can also put a grid by just writing grid. That easy, okay? So I'm going to run all that and see what happens. Please wait. So the grid made this little grid appear, makes it easy to look at the values. We've got a title, and then you see in the blue, let's zoom in here. You see it says the blue line is θ equals 30 with a little circle, 30 degrees. That was the LaTeX code. You don't need to perfect this, but if you want to get really nice figures, you can do that. And when you save it, it will look even nicer. Okay, so that's task 4, that's plotting. I think that's enough for right now.